Okay, so now I'm recording, okay? So then you need to follow the handout. You create a new project, first of all, okay? And give the project name is 8.1, and your name, author is your name, okay? And then make sure you need to select the device. All right, so in our case, we need to select NJ101. All right, and the firmware version, we choose 1.1. Okay, and click create. All right, so once you create, you can see the window like this. And then you go to the left-hand side, configuration and setup. All right, click on it. And then go to the second one, CPU and expansion racks. Everybody follow? Let me know if you're lost, okay? Then you right-click, edit. Right-click, edit, okay? So now you can see this. So the left-hand side is a power supply, which is 24-volt power supply, okay? And then this one is a controller, which is a NJ101, just now you choose from beginning. So now we need to add in the digital input output rack, okay? So what do we choose? Okay, refer to your handout. First of all, you'll go to the basic I/O, click on the basic I/O, and then you just scroll down. Okay, CJ1W, 1D, ID 201. Okay, right click, insert. All right, so this one is the input module. Similarly, we need to add another output module, okay? So we scroll down a little bit. So let's see, okay, ID means input, digital input, okay? So now we're looking for OD, output, okay? CJ1W, OD 201. So this one is the output module we're going to choose. Insert. Okay? So now we got all the hardwares we need. All right, so these are all hardwares we need, okay? Then the next is we click on the I/O map. Double click. All right, double click on the I/O map. So now you can see your CPU rack 0 there, okay? And click on the arrow to expand it. So you can see your CJ1W 1D input unit is here, okay? And then you click on the CH1, stands for channel input. All right, you can see this. Be careful, now it's very important. Because now we need to assign the variable to this one, okay? We need to configure the input signals in this PLC, okay? You see this one word here. Don't fill up anything here, okay? Because this one is the word, the type. We need to start from this one, the Boolean. DOL stands for Boolean, means true or false, open or close, all right? So we start from this one. So the first input we need to type is SW, stands for switch, okay? SW1. So once you click on, once you finish and click the next row, so you can see automatically at the back, the data type, the variable type is a global variable. Okay. So same thing, go to the second row is a switch 2. All right, and click. So you can see the variable type come again. Next one is SW3, switch 3. In total, we have 3 switch, okay, for this exercise. Okay, once again, don't type the name of the input to the first row, which is the word here, okay? The first one is the second row here, Boolean, first one, okay? So now we finished the input signal. Now let's look at the output signal, all right? So output signal is here. Okay, so just now we click on the ID 201. So now we click on the OD 201 and click on the arrow. So now we can see these are the output signals. Okay, but we only need 3 of them. So once again, please don't type anything behind the word. All right, we need to start from the Boolean. All right. So the first one is a capital L 1. Okay. The second one is a capital L 2. Third one is a capital L 3. All right. Then automatically the variable types will be assigned as a global variable. Okay. So this part is the configuration of the PLC. All right. Input and output. Okay. So after that, we need to start to design the logic. All right. So we are using a ladder diagram for PLC. That one is very classic. Okay. So you can see here programming going down the section 0 and the program 0. So double click on this one. Everybody can find it. Double click on this one so you can see this window here. All right. Then the next thing is you need to just follow your handout. All right. So here is the ladder diagram for this exercise. Okay. So you just follow it. How to do it? 2-way. You can either click on the C on the keyboard, C. Okay. So you can have the input, or you can right click on your mouse. You see input, insert output. So they're either one of this way. Okay. C here, you try. Okay. You type C, you can see there one new input come out. All right. So then you double click on the top to rename it SW1. Okay. So which is the switch 1. All right. And then you just once you finish the first one, you just go to behind and highlight this one. Type C again. So you can insert another new input. But this time the logic is opposite, right? So you right click on the input. Right click on the input. Can you see the invert? You click on the invert. All right. So you can see now we have the opposite logic here. And once again, we need to rename this one as SW2, which is switch 2. Okay. So same method, insert another one. Okay. SW3. All right. And then output. Output is your O. O on your keyboard. Okay. O output. Okay. Or you can just right click again and select the insert output. Same thing. Okay. So the first one is L1. Okay. So now you see the first row, right? The first row, actually, we have another parallel input in the beginning, which is L1, right? So how to get it? Right click on this one. Can you see insert parallel input below? Click on it. Everybody follow? Okay, good. So you see, once I click on this one, so I have a parallel input, right? So please rename it as L1. Why do we need this L1 here? All right, so this one actually is a very special thing about PLC ladder diagram, okay? Only in ladder diagram you have this kind of thing. We call this one latch. Latch means, for example, right, without this one, without this L1 here, L1, we know this one is output, right? So that means, yeah, if we, let's just imagine we don't have L1 here, right? And then we just turn on this one, close this one, and then we see the L1 is moving. Right. Then, for example, you have a switch with the pulse signal, you send pulse signal to this one. That means if we don't have this, right, it's just a pulse, means you only start the motor, give a pulse signal, but when you release the button, it's off. Right now. That's why we need this one. We call this one latch. Means once you trigger this one, so this one turn on, right? When this one turn on at the same time, this one will be closed. You call the same thing. So then once this one is closed, it's always on. All right. So that means the motor on off is not rely on the SW1 anymore. This is the meaning. Okay. Unless switch 2 and switch 3, one of them are done. That's all. Okay. So once it's off, so this status of this switch here is changed again. Okay. All right. So this is the first line. So if you don't want to type again, okay, I can show you an easy way to do it. Okay. Go to the 0, right click, copy, right, and then go to the below and paste. Paste. All right. Because they are the same pattern, the only difference is the name. Okay, maybe I can just copy another line, okay? Because they are all the same. The only difference is the name is different, okay? For example, the second row, the first one is the switch 2, right? And then this one is switch 1. And then this one is the switch 3, sorry, switch 3, don't change, and then the output for the second row is L2. And then the latch here is L2. Oh, okay. Look at this, look at here, okay? You go to the first row and highlight this one. Become green, right? Blue. Right click. Copy. Okay? Copy and paste. It's not locked. Actually, it's not locked. So the rest is we just follow the handout to change the name of the different inputs outputs, okay? Give you some time. All right, so once you finish the ladder diagram, so you can just go to the project, check all programs, or just click on the F7, up to you, okay? Either way. So then you should see there's no error and warning, okay? Right here. Okay. So if there's no warning and error, means your ladder diagram is okay. All right. Then the next step is we can go to the view tab here, click on it, and you look for simulation panel. Okay, so once you click on this one, you can see a window come out at the right bottom corner here. All right. Then you just click on the run button or F5. Okay, to run the ladder diagram. So you can see now it's starting the simulated building. All right, you can see the progress here. Wait for a while. All right, so when it's running, it's like this. You can see the input here, it turns into green. All right, so once you reach this step, you just right click, then you will see when it pop out, you can just look for the set reset. You click on the set, means you set the whole system, okay? So once you set it, you can see these two are connected, all right? And then the L1, the motor one is running. From where? From right click, okay, sure. We'll go to the switch one, right click, set reset. Just now I set again, I set already, so now I only have reset. You should have set. Click on the set, yeah, set. Set. Yeah, set means on, yeah. So then, because the next page, right? They assume we have the hardware, but unfortunately, we don't have hardware. Okay, we only have simulation. Okay, so this is show you if you have a real physical PLC controller, how do you connect this one? Connect the switch. Okay, 3 physical switch to the PLC controller and to control the motor. Okay, turning on and off. Okay. So that's the end of the lab 1. Easy? Quite straightforward, right? Test, yeah, test you about this one, yeah. Okay. Don't worry, okay? The test will be same as your ABB one, okay? I won't fail you, okay? Don't forget, don't worry. You need to save it. Okay, save is go to the file. Go to file, click. Okay, stop it first. Sorry, stop the simulation first. Stop the simulation. Okay, right hand bottom corner, right bottom corner here, stop. All right, so you see the color change back to the white, right? Just now it's gray. Then you go to the file. You can see the save and save as, right? Up to you. All right, this is the way you'll save it. Okay. Oh, okay. So let's see. So one of you didn't submit your practical test one. Okay. You can submit now. Okay. Yeah. Only one student. Yeah. Only one student. Okay. All right. So this is the end of the lab 1. So lab 1 is the easiest one, okay? Lab 2 is more difficult. The most difficult is lab 3, okay? You want a break or continue? Continue or break? Continue. Continue. Okay, toilet break. You want to collaborate, you can just go, okay? I will try to do slowly, okay? Make sure when you come back, you still can catch up. All right, so this is the end of the lab 1. Please save it and close it, okay? Close it, you can just go to the file again and close, okay? Click on the close. Someone's coming. here. Okay, I can just show you. First of all, I will show you the lab 2, the ladder diagram, what it looks like. All right, because this one in the handout is not clear because they don't give you the whole ladder diagram like this. Okay, so that's why I just want to show you this one, and then later we will do it together. All right, so you can read the first page of the lab 2. Okay, so you know what is the application is, why the logic is like this. Okay, so we can see exercise 2, the bottom here, the first page. Use TON on delay timer. All right, instruction in a ladder program to make the single way escalator program more smarter in energy saving. All right, the escalator will stop in 5 seconds after last person passes the sensor. Switch 1. Okay, located at the end of the escalator and the motor L1 of the escalator start to move when sensor 2, SW2, switch 2. Okay, which is located in the front of the escalator when someone approaches it. Okay, so that means for this application, you've got 2 sensors. One is the starting, and another one is ending, and then you've got the one actuator is L1, which is the motor to drive the escalator. Okay, these are 3 things. Then in the PLC, you have one timer, which is a 5-second timer. So when the last person stepped out from the escalator, 5 seconds later, this one will stop. Okay, this is the thing you need to design. Okay. So that means you don't have this one. You don't have direct X eleven. That's right. Because the hardware is not support. The hardware is not support the software. Because we don't provide hardware for this. Huh? Oh yeah. Yeah. All right, class. So for the exercise 2, lab 2, you need to refer to the lab 1 because they are using the same controller. Okay, you follow the same steps in the beginning when you try to configure the controller type, the model. All right, and then how to add the input output units to the rack. That step is same as your lab 1. That's why you need to You can see from your page 2 of the lab 2, the first row is refer to 1.1.4, writing and the algorithm of the lab 1. Okay, so you need to refer to lab 1 for the first part to do the configuration. All right.
By using that one.
Okay.
For the
data will be different. Okay, only the ladder diagram are different. Okay, the configuration is same. Okay, we'll do it together. Let me see. So I assume the first part you know how to do it. The lab name, the author, the model of the controller is NJ101. Okay. Firmware version is 1.1, is same as your previous lab. All right. And then after that, okay, we go to the CPU expansion rack. Click on edit, right click. So now you see these are the same, right? Same hardware units, same as the lab 1. Okay. You are right. The I/O mapping is different because your ladder diagram is different. All right. That means your input output will be different from the previous lab. Okay. So now, first of all, you have to make sure you finish this part. Okay. So this part is same as your the previous lab. So once you've done that, okay, so then we go to I/O map. Double click. Okay. Once again, go to the CPU rack 0. Okay. Click on the arrow. All right, so you can see the input output, right? Input output unit. Click on the input unit first. Okay, channel 1 input. Click on it. Okay, now please refer to your handout. All right. Procedures number 2: create SW1, SW2, timer 1 up inputs. Okay, you got 3 inputs now. Okay, the name is SW1, SW2, and the timer 1 up. Okay. So these are different from your previous lab because the previous lab is SW1, SW2, SW3, right? So now you have a timer 2, sorry, timer 1 or timer 2. Timer 1 up. All right, my apology. Typo here. Okay. So once you configure the input signals, now we move on to the output signal. All right. So once again, please be careful. The first one row word, you need to leave it empty. You always start from the Boolean, okay, Boolean type, data type to enter the first input. All right. You need to skip this word, same as your output signal. You can't write anything here. If you write anything here, your system won't run. Okay, it will keep popping out the error message. Okay. It is just Boolean, yeah, yeah. Okay, so once you've done the I/O map, the next thing is you need to look for the programming. Okay, programming, and then go to the section 0, program 0, section 0, double click on it. All right, so you can see a blank window like this, but for my case, already done all the ladder diagram, but don't worry, I will go through this one by one with you, okay? So because you got the first empty row, right? And then once again, please click on the C button. So you can insert a new input. Remember, click on C. So you can have this one. And then click C again. Behind it, you can have this one. But remember, rename it. Okay, rename the signal. and click on the O button, so you can have output here. Okay. So don't forget to rename the switch. Okay. Okay, so if we have done the first row, now we need to see the parallel input. Remember how to get the parallel input? Okay, right click on the button, right click here, insert parallel input below. All right, then click on it. You can have an empty input here, and then please rename it, okay, as L1. Okay, then if you've done this one, so the next one is a bit tricky. All right, so I will do it again with you, okay? I will delete this one and we do it together. So, yeah.
Switch one, switch two. That's my switch. Switch two.
Switch one.
Switch two.
Okay, switch to, okay, go to the first page. There are two sensors, right, for the escalator. One is in the beginning position, another one is the ending position. Two sensors at both ends.
Yeah.
Switch one, switch two. Okay, first page, go to the first page. You'll see the description here. Correct. So in total, we have 3 hardwares, 2 sensors, and 1 motor. You know where is it? This one, the description. So you've got 2 sensors. The first sensor is when you're passing. This one is switch one. And then when you step out, there's a switch two. So you're doing this parallel. Okay, so how to add the switch tool for the first row? You right click. Once again, insert parallel input below. So you can have this one, right? And then please rename it. So this one is a switch 2. Okay. So once you add this one, but we can see here is connect to wrong place because this one is supposed to be at the end of the timer 1 up, right? So what you should do? You highlight this one, and then mouse left button, click and hold. Go here. Okay, and then release. So now you can see pop-up window. Okay, go to this one. Move vertical line. Move vertical line. Everybody with me? Click on it. So you can see now this line go behind the timer 1 up. Please remember this, okay? Okay. Everybody got it? Okay, let's continue. So this one is the first row of the ladder diagram. All right. Then we move on to the second row. The second row is, first of all, we need to insert 2 new inputs. All right. So the first one is L1. The second one is SW1. But this time, okay, don't forget, this one is invert. How to get the opposite logic? You right click on this one, and then you're looking for the invert. All right. Then you can have this kind of a slash things there. Okay. So for the second row, we can see after the two inputs, we need to have a function block, which is a timer one. How to get it? Can you see the toolbox window here? And we got the search window here, right? So you just type in TON, enter. So you can see at the bottom, you can see this TON block, correct? Can you see this one, everybody? This one is a TON. This one is the search window. You type in TON here, and then at the bottom, you can see this TON block here. All right. You just mouse left click, hold, and drag to here and drop it. So you can have this one. Okay. TON. Then you go here. Then you mouse left click and drag this way. You see? Also can. Please check whether you got the same pins or not. Okay. Yeah. That means 5 seconds. Remember, in the beginning, the description, we need the 5 seconds later need to stop, right? So this is information about the 5 seconds to key in here. Okay. Then please remember to rename this timer one. Okay, this one is timer one. So this is the first part of the lab 2. Okay, this one is the second part of the lab 2. Okay. So now up to here, we already done the first part of lab 2, which consists of 3 ladder diagrams. All right. And then the next is once you have done this, the next thing is we need to once again to get the simulation panel. All right. So go to the view and look for the simulation panel. All right, so then once again, you can see this small window here. Click on the run button. You just follow the handout will do, okay? Click on the run button. So wait for the system to build the ladder diagram. All right, you run first. All right, so once it's running, so the window color will be turned into gray, okay? And then you double click on the SW1. All right, so now we can see the status of the input. Okay, so we can just toggle the on and off, which is true and false. Okay, same thing. You can toggle this one, then you can see the behavior of the system. Okay. Then the third step now is to go to the variables. So once you go to the variable, you can see the window open up, right? Then we can see a list here. This list is all the variables we is involved in this ladder diagram. Okay. Yep. Question? Errors. Very likely is the name of the default. That's the variable for the previous step. So let me see. Okay. Something is wrong. They definitely will have the boundary. All right, so this is the first part of the lab 2. Okay. So you need to be careful. Is the letter is okay? It's case sensitive. So for example, you define the name in the IO map is a small letter, but you know, in the letter diagram, you give the capital letter for T, then it won't recognize. All right. So it's case sensitive. Make sure the name, when you name the block here, all right, you have the same name when you define it in your IO map. Okay. Also for the timer, this T here is also must be capital T. Okay, cannot be small t, lowercase, it won't recognize. So actually later when you finish complete the whole letter diagram, right? When you run it, you can see the thing is running. Okay. All right, shall we continue? Okay, second part. Okay, 2B. So just now we already complete the first two lines, right? And then now we move on to the third line. First of all, we need to add a new row. Okay, we need to add a new row here. So we already got. Okay, let me just close this one so we can make it bigger. So this is what we created just now, and then we continue from this line here. Okay. Right click, create a new run. Sorry, we need to stop this one first. You are right. Okay. Insert a new run below. All right, then you can have this row here. The first of all, type C, you need input L1. Okay. Then after the L1, you press the I on the keyboard. Then you can have a block like this. For example, I'll do it again. I here. Can you see? It's a new block come out. All right. And then what you need to do is you need to rename this one to the get time. Get time. Okay. Let me just delete this one. Okay. Get time. So once you key in the name, I will double click on the enter button. So you can see the block becomes like this. Got 3 legs here. Okay. One is enable, another one is enable 0. O. Another leg is the start time. So similarly, okay, one more thing. The different thing is this one. What do I mean by this one? Arrow up. Can you see this one? This means rising edge triggered. Do you know what is rising edge triggered? We got 2 things, right? One is a state trigger, another one is a edge trigger. Okay, so there are 2 types of trigger signal. Okay, one is For example, like this, right? So here, this one is going up in this way, okay? So the signal travel from left to right. So this one is only be triggered by this one, but this signal going up. Okay? Rising edge triggered, rising edge. This one is same, falling edge triggered. Okay, this is the meaning of it. Okay, edge trigger. Okay, so how to do that? Right click, diff up. Yes, you're right. Okay, diff up, differential up means it's an arrow up. Okay, so diff down is a arrow down. All right. This is how we get this two. Okay, the next row actually is same. Only the switch, the input signal is a falling edge. Okay, and then the get time block is same. The difference, only difference is this leg here with end time, because just now we start time here, then we got end time here. Okay. So once you got this two row here, all right, for the last row, you need to add another new block, which is the subtract date and time. Okay. So same as this block here. So you just key in the I, press on the I key. Then you can have a new block, and then you need to rename it to sub underscore dt underscore dt. Okay. Then automatic and hit enter twice. Then you can got this block here. Then you need to rename the input 1, input 2, and the left tab here. Okay. And that's it. Sorry again? Round number 3. No, it's not like this. It's not like this. It's not like that. Just too close, too close. There is a gap. Go warning. It's that time. The warning actually you can ignore. As long as no error is okay. Because I believe that one is a version issue. Because my version is okay. All right, so now because we already got the running the PLC, right? So now actually we can test the logic whether it's correct or not. Okay, just imagine now I just turn on this one. All right, and then I turn off this one, but then it's still latched. So now the timer already count. 5 seconds later, you can see. You can see the motor is stopped right now. So actually, this is the correct logic. We can check this way by running the simulation. Okay. So that's the end of the part 2, part B. All right. So then we have we have part C for the lab 2. All right. So let's continue. This one is a bit more complicated because it's involving array. So please save it and close it, okay? And you must open a new project, all right? So if you want to save it and use the same project for the next exercise, you will got some mistakes, all right? Because at the back end of the software actually already saved some of the variables into the system, all right? So it will give you the very weird mistakes. So please create a new project, okay? And then we do from beginning, okay? So same thing, okay? Okay, be careful. This time, something is different. Let me see. All right, you are using the same device. All right, NJ101 version 1.1. Okay, same thing. Then create. Then go to your CPU expansion rack. You need to add the input unit, output unit. Okay. So this time the input unit is digital input, which is the same as the previous one, which is ID 201 input. Okay, but for your output, so this time is analog output. Okay. Analog output, you can refer to your notes, page 22. And sorry, page 9 and 10. Yeah, total page 22, sorry. Okay, bottom of page 9 and the top of page 10. All right, that one is the selection of the input unit and output unit. So once again, the input is digital input, is same as before, but output unit this time is analog output. Analog output, okay? Analog output, the name is CJ1W MAD for 2. Make sure your output is analog output, okay? So once you get the input unit and output unit, the next thing is we need to configure the input output, right? Remember the name of the input output. Double click on the IO map. All right, CPU rec 0. So this time you only got one input, which is PH1. Capital letter, please. PH capital letter. No space in between, okay? PH1. All right, output is small letter, data 1. Be careful, you need to see where to put the data 1, all right? The data 1 should put under CH1, channel 1, capital R, D, capital AI. Okay, the data type is integer. Make sure you put the name at the right place, all right? Everybody follow? Output data 1 must be under here, must be CH1 and RDA1, must be under this row, okay? Cannot be the other rows, must be this one. All right, so once you got this one, once we configure the input output IO map, then we go to the section 0, double click. Then once we got this window, we go to the variables. Okay, we go to variables, and then we go to the internals variables, okay? And under the O data, we need to type in here, O data. Make sure the case is sensitive, okay? Make sure the beginning is the capital A and the data D is capital D. And in between is the underscore. So this is the name of the variable. So once you type this, the next is a data type. You need to type because this one is array, all right? So please use all capital letters for this. Just follow the handout, okay? Array, square bracket, 0, 2 dot, okay? 2.9, close bracket. Space of space integer, int, all capital letters. So once you type in the information, the next thing is you check the retain. Yeah, okay. You tick in this square in the box. So this is our first variable. All right. So once we done this part, the second row, okay, we do this. Look at here, mouse, right click, create new. Okay, for you, just now you only got one row here. So once you create new, you have a second row. Then you need to rename, give a name of the variable, which is n, small n. Okay. Data type, int, integer, capital letter. Initial value, we start from 0. Okay, so once you've done that, so that's then we finish the configuration part. Okay, the variables. We have already created all the variables we need. All right. So we can just click on the variables again to close the window to see only the ladder diagram. All right. Okay. So once we finish this step, the next step is to create the ladder diagram. All right. So the first component is the input again. So we just type C. We can have this one and right click to select the div up to have the arrow up, which is rising edge. All right, and rename this one as a PH1. Capital letter, please. PH1. Okay. All right, so once you create the first component here, the second block is move. So you just go to the right column here, and in the search window, you just type in move, MOVE, enter. So you can see the move block is here. We just drag this one to our ladder diagram, first row. Okay. So once you have this block here, your input signal now we put to data 1, small letter. So once you key in D8, then you can see this one is a pop out automatically. You just click on it so you can have it. All right. And then your output signal is all data. You need to type this one on. Oh, yeah, square bracket n, yes. So once you finish the move block, the next thing is we need to go to the search window again, type in INC, all right? Everybody follow? So once you finish this part, that's the end of the ladder diagram, okay? Then we go to the view tab on top. Yeah. View. We need to open two windows, okay? The first one is watch tab page bracket table. This one. This one, okay? You click on it. And then we go to the same place again to select watch tab page without bracket table, okay? These two, one is here, okay? So now you can see my window here. Actually, I have these two pages here. One is a watch bracket table. Another one is watch bracket project. Okay. So now you click on the variables on top of the ladder diagram here. And we click on the internals. So we can see we have all data here, right? So we just click on the all data and drag it to the watch table. I already done this one, so you can see it's like this here. Got it? All right. So once you have this, the next is the same. We need to have the simulation panel. View simulation panel again. Click on it. All right. So you can see the simulation window comes out. And then now we need to test the function block, right? So now we change the data one here to a number. Okay, according to our handout, we can test 222. All right. That means we need to replace the data one with 222. All right. So this is the input information. All right. Move. Okay. Move block. Input, we change it to 222 here. Okay, 222 here. Okay, then we'll click on the run button in the simulation, run it, wait for a while, need to build. Be slow. All right, so now it's running. All right, so once it's running, we click on the pH1 switch rising edge detection. Okay, so double click on it so you can see this toggle button comes out. Okay, so now we can click on the true, false, true, false. Okay, by toggle the switch, please observe the changing of this window here. Okay, every time when you toggle the switch, you can see a new value comes out, which is the 222. Okay, now let me just slowly demonstrate. Okay, true. Can you see? Can you see a new one come out? So this is the function block. What the function block do? Okay, this one. All right. Can you see this one? All right. So now we stop the simulation. We stop the simulation again, and then we change the value of the input to different values. Okay, now this time it's 333. We change to 333 and then we run it again because we want to see what is the behavior of the system. Okay. So now we toggle the pH1 switch again, so we see what is output. So slow. Okay, so now we toggle the switch. So now we can see the value is changed to 333. Okay, every time I toggle this one, actually my array elements is changing. All right. So why when it's reached 9, then I continue toggle this switch here, but the array won't increase. It's because we define here, right? We define the array size is from 0 to 9, which is you got 10 elements in total. All right, that's why once it reaches to the 9, you toggle, you keep a toggle this one. Actually, there's no more. Okay, no more comes up because the size is already, I mean, filled up with the values. Okay. All right, that's the end of the lab 2. You want a break? Okay. 5 minutes break. Okay. All right, please have a look the lab C, okay? Lab 3, sorry. Lab 3. So if you are using version 1.25 and below, you can open the simulation later, okay? For this lab 3. But if you use the version above 1.3 1.25, I don't think you can open the simulation. Okay, the 3D simulation, but I will show you here because I'm using 1.25. Okay. All right, so you can follow the handout. We can start to follow the handout and try. Create a new project, and then this time the device is different. Okay, the device is NX-IP2, NX1P2. Okay, the version is 1.13. It's not NJ101 anymore. Okay. So once you select the device and create, you will see a window like this. And then you need to go to the right-hand side, go to the configurations and the setup. All right, and then go to the EtherCAT. Double click on it. Double click on it and then go to the servo driver. Okay, click on this one. And select this one, R88D1SN01H ECT. Okay. You just drag and drop, drag and drop. Drag this one to here and drop, then you can see this. Okay. So once you got this, then you go to the axis. You go to the axis setting. Yeah, this one. Right click, add. Then select the single axis production control axis, okay? Position control axis. Then once you add this one, you can see it's here. All right, it's beneath the axis setting. You got one new axis. Then you double click on it. Double click on it. So first of all, you need to check the axis type. Axis type here. Make sure it is a servo axis. Okay, and then output device one, you need to check your output device one must be RDD, the hardware you just now you add in. All right. So once you've done that, you need to go to, you see this here, the icons, the big icon here. You need to go to the second one, measurement. unit conversion setting. Okay, this one. Click on this, then you will see the unit of the display. So we use pulse. Okay, and then we need to make sure the two values here must be 10,000, 10K for this two, all right? The first one is the travel distance. Okay, the second one is the pulse per revolution. So that's the only two things you need to configure in this window, okay? And then you go to the encoder. Position count setting, this one is for encoder, all right? So we just need to check the encoder type is incremental, that's it. So this is a setup for the system, all right? And then now we move on to the B, section B. Okay, we need to construct the ladder diagram. All right, in the first round, the first one is a start. Okay, is the input. And then in the search window, we type MC underscore power. All right, so then you can have this. You can obtain this block. Then you have this block here. All right. Then please rename this two, okay? The input and output for the axis. Change this one to MC capital letter underscore capital letter axis 000. Just follow the handout, okay? And rename the block to power 1. Follow the letter, okay? P is capital. Then once you got this one, you need to add an output for the first round, okay? And rename the output to the power 1 underscore down. So once you have the first round, then we move on to the second round, okay? For the second round, it's same. You need one input, one output, and a function block here. So the input output, you know, all of you know how to do it. The function block is just you go to the search window, you type in MC_home. All right, so you can see this function block here. You just drag this one to the second round. And just follow my ladder diagram here to rename this one to home1. And rename the axis to the same as the first round here, okay? And don't forget to rename the input and output of the second round, okay? So the last round actually is you have two inputs. Okay, the first one is a home, one underscore done, and the second one is a move done. Okay, this one is invert. And then the only different thing is that these two function blocks is move. All right. So you, once again, you go to the search window here, you type in MC_move. So you can see the MC_move function block comes out. You just drag this one twice because you need two. All right, you need two function blocks of the MC move. So because now we're only involved in one axis, the axis name is MC_axis000. So that means we need to change all the axis name to the MC_axis000, okay? Why use two move? One direction, another direction. So please double check the name for all the input and output, okay? Make sure it's correct. If its name is wrong or repeat, you cannot run. The simulation cannot run. Okay, one more thing, be careful. For the last round, the move one, move two block, for the position and the velocity, All right, so you'll see the first move is 1,000 and velocity 1,000, right? Just now someone else asked me why there are two, because this one you see the difference. This one, the position is minus 1,000. That means these two move block, one is move forward, another one is move backward. All right, that's why you need two move blocks. Okay, but you see the velocity is going to be the same. That means we only change the moving direction of the motor, but the speed is going to be the same. All right. So these two things you need to change. Be careful.
What do you need for these two? You need
Unit.
for the what is here the
Okay, so the unit is mm for the speed. Sorry, for the position. So in other words, this one is 1 meter. All right, the velocity is same, 1 meter per second. So do you know what is jerk? Everybody? No idea? Jerk, J-E-R-K. You see this one? No idea. All right, so it's about motion control. All right. Do you know what is Do you know what is acceleration?
Yes.
Wow. Okay. So, all right. So, okay, we start from this. Okay. We know what is the displacement, right? Displacement. What's the displacement? Distance, right? What's the difference between distance and the displacement?
Direction, no direction.
Very good. One is a scale, another one is a vector, right? So displacement we got direction. That's why here position you got plus minus. The sign actually represents the direction. Same as displacement. Okay. So we know displacement. So this one is, let's say the unit is meter, right? Meter. We got direction. And then what is speed? Velocity. Velocity is what? Displacement divided by. Okay, so that's what I got meter per second. Right? What's acceleration? Acceleration describes the changing of the speed. Right now. Is what? Means what's the unit for the acceleration? Meter second square, right?
Yeah.
What's the jerk? Jerk is describe the changing of the acceleration. Okay, so in other words, this one is. Got it? Why we need this? Okay, so because I know you are from some of you are from motor industry, right? From motor and control things. All right, so the thing we talk a lot, okay, in the motion control is motion profile. You know that, right? Motion profile. So this one is E. This one is T. Okay. So that means B is your y-axis, T is your x-axis. All right. So may I ask you what's this? The slope, the gradient of the slope is what? Very good. Acceleration. Okay, this one is A. Acceleration. How about this one? No acceleration, right? Cruising. Cruising. Okay. Means the constant velocity moving. and then you break it down, right? Break it down. Deceleration, right? Decel. Where is jerk? Jerk is here. Jerk is here. You describe the change, the transient, okay, between one acceleration to another acceleration. That's why it's jerk. We need, okay, we have another word, another name for it, smooth factor. You see this one before? No. Smooth factor describe how smooth, okay, between your acceleration and your cruising. This part is a smooth factor. It's also called jerk. Okay, we need to smooth out these two sharp angle here to make sure between the acceleration and the cruising constant speed, the connection there must be smooth. Okay, then we need to adjust the jerk to make sure the transient is smooth. Okay, that's why you can see for the move function block, you got acceleration, deceleration, then you got this one, jerk. Okay, now you understand that? Okay, let's continue. All right, we just follow the handout. So now we already complete the ladder diagram. All right, then we need to do some setup. Okay, so first of all, we go to the simulation. Sorry, no simulation, my apologies. So it's here. Go to the left column. All right, to try to find the data trace setting. Right click, add data trace. All right, so once you click on the select data trace, you can see this one as mine. Data trace bracket. How come? What happened to this one? This one, okay? This one here. Then we double click on it. Previous tracing result exists. Do you want to load it? No. All right, so you can see this. My one already configured. So then you should see something like the top. Okay, and then you click on the. You need to enable the trigger condition. Okay, so this one. Check this box here. Check this box here and rename this one here. Okay, rename this one. You just follow the name in the handout. Okay, and check the box here. Okay. All right, so once you've done this part, this step here, so you need to click on the add button here. Okay, you can see the sign here. You click it one time, then you'll see the yellow tag there, and then you need to give a name of this one. Make sure the name you follow exactly in the handout. Okay. This one is MC axis 000.cmd.pose command position command. Okay, stands for position command. So once you add the first one, the position command, and then you go to the you need to find the simulation panel again and click on it. Okay, then we run the simulation. So once the system is running, you need to check there's no error and warning. Okay, maybe you got warning, but definitely no errors. All right. So once you check this one, no errors. You see this one? Start tracing. The red button here, you click on it. All right. So once you click this button, if it's successful, you can see the bottom left corner. The information is waiting for trigger. Okay, that means this one already been triggered successfully, activated successfully. All right, trace is activated successfully. Okay, and then you go to your block diagram. Ladder diagram. It's here, section 0. Double click on it. All right, so now you can see your ladder diagram here, which is running. Okay, and then we go to the first row here and double click on the start. Okay, to find the toggle button here, true and false. You click on the true, and then we observe the progressing bar, okay, and sampling. You see that it's running, right? So we can see this part is blinking, so it's running, you see? So the system is running, right? Right? This part, you see, is running, huh? So once it's running, we go to the, just now we open the data trace tab, right? Yeah, this one. We click on it. So now we can see this is a response of the axis, the motor. So my screen is too small, so I cannot show the proper image of this plot here, okay? Ah, this one is better. This one is better, right? So then we click on the 3D button here, 3D. So, okay, we click on it. And then we click on the 3D equipment model menu to add the new model. Let me see, huh? Where is it? Okay, so now we go to the, can you see this line here? All right, click on this button, display 3D equipment model menu. Add. I know your version's problem. That's a problem. Okay. And then we select single axis position control. All right. So for this part, right? If you're using higher version, new version, so you don't have this one. Okay. No worry, I can show you. Sorry again. 1.13 should be okay. Okay, I just show you. Okay, for example, we open this one. We select the type is a single axis position control, and then we select the axis. We just now rename it, right? MC axis 000. All right, and then we change the 3D size. And then we click on OK. Loading trace. Click on the start button. So now can you see, I mean, the motor is moving forward and backward. I mean, it's too small. I don't know why. Let me see. To make it bigger. .25 and below got 3D. So can you see this one is moving here? I don't know why the window is so small. But you can see the block moving, right? So this one actually is the motor drive this one to move forward and backward. So this one is the 3D simulation now. You see this is running time, right? But I don't know why the window is so small. You cannot make it bigger. All right, it's here. Huh? Okay, so that's the end of the lab 3. Questions? No questions. Okay, so I think your lab test 2 will based on this one. Okay, PLC. It's about Sysmac. Okay, but don't worry. So I will be here to help you. Okay, everywhere will pass. Okay, if no questions, have a nice weekend, everybody. Okay, see you next week. Yep. Sorry again. What's the question? So we'll be testing on the 3D part, okay? We'll be testing on the Okay, welcome. Bye bye. So I will send the record to everybody. Okay. Maybe because it's very big, so I will send to through the MS Team. Okay. So once I upload to MS Team, I'll let you know. Okay, welcome. Okay, bye bye, bye bye, welcome, bye bye.